Okay. Good afternoon, all. Today we are going to discuss regarding the operations performed on independent variable. Dependent variable operations we have already seen in the previous session. That is the operations on amplitude scaling, addition, subtraction, multiplication, and differentiation and integration. Today we are going to deal with the operations on time variable T. In a continuous time it is a T, in discrete time it is a small n. The first operation that we are going to see today is the time scaling. Scaling is again a familiar term to you. Just like amplitude scaling, we have time scaling. Remember, the major difference between those operations and this dependent and independent variable operations is, in earlier case, when we were dealing with dependent variable operations, we were concentrating on vertical axis. Amplitude variations were occurring. However, the time we did not touch. Okay, the time was kept as it is. Whatever the range that each signal has for the time, the same is kept as it is. Only the signal amplitude has been varied. If you do any operation like addition of two signals, multiplication, the time is kept as it is, only the amplitude variations have occurred. But here, when we are dealing with the independent variable time operations, we are concentrating on horizontal axis, that is time. We are not touching this vertical part. Whatever signal amplitude is there, the same amplitude we are going to keep it after these operations. Only the change is in time. Remember this. This is a major difference. So let us start with the time scaling. Again, here we will see the continuous and discrete both. Let x of t be a continuous time signal. Then the signal y of t, it is obtained by scaling the independent variable time by a factor small a. There also in amplitude scaling we have taken small a only. Okay, but what is the difference? See here, it is given by y of t equals to x into at. Just try to compare this with your amplitude scaling. It is actually there in amplitude scaling, it is like this, a into x of t. Here a is inside the bracket, here a is outside the bracket. Outside the bracket indicating amplitude, inside it is associated with time t. Okay, remember, that's why this is vertical axis amplitude, this is with respect to time. Hence horizontal axis is important for us. Here again we'll be getting two conditions depending on the a value. If a value is a whole number greater than 1, then your signal what you get when you do this time scaling operation, if a value is more than 1, say 2, 3, 4 like that, then your output final signal, it will be compressed version of x of t. Compressed. Okay, you know what compression means. Okay, it is tightly bound. The original shape, if it is something like this, the compressed version will also look the same way, but like this. Okay, this range is bit bigger, this range is bit smaller, so compressed version. Similarly, if the a value is between 0 and 1, that is say 0.5, that is 1 by 2 or 1 by 3, 1 by 4, any value between 0 to 1, fraction value, then the output what you get, it is expanded version. What is expanded? Compression and expansion are opposites. Okay, so expansion, how you write, this is your expanded signal, you know, the range is now expanded. Remember, this is your original signal, this is your compressed version, this is your expanded version. Okay, this is the theory behind time scaling, how the time scaling is performed. Now with an example, let us try to understand time scaling. Sorry. Okay. this is one example taken. This is one signal x of t given to you. See, this is horizontal axis, vertical axis x of t. If you see the time range, it is -2 to 2. Okay, and there is a step here, one step and two step. Similarly, two steps. So this is one example. X of t is given to you. You need to find x of 2t. The value of a given is 2. Okay, so which one will apply, first one or second one? Condition first will apply, a greater than 1, because the value of a is 2. So here we know it, if the value is greater than 1, then you will get a compressed version, right? So how to get this compressed version? Let's see. What you have to do is, whatever signal I have drawn here, let me show you here. One more time I will draw. You also try to draw along with me. This is your horizontal axis. This is your vertical axis. Now the vertical axis is x of 2t. You are finding x of 2t. Okay. Then what is the range of x of t? It is -2 to 2. Compressed means obviously range will get compressed. Okay, it will not be 2, it will be less than 2. Hence, we will simply mark it. Let's see what will happen. Okay, I have marked some points here. This is your 0 point. Now, whatever value a is given to you, which is greater than 1, you have to take that value and you have to divide that value by all the time. See, what is the time here? It is -2 divided by a. A is 2. Here it is -1 divided by 2. Whatever a is given to you, that value should be divided to all the times. 0 by 2. Here it is 1. 1 by 2. Here it is 2, which is 2 by 2. This is the first step in order to find time scaling. Whatever a value is given to you, that should be divided to all the times. Okay, this is the first step. Then second step, try to calculate this value. It will be -2 by 2, which will be equal to -1. So at -1, I will write it here with a different color, you will understand. This new value is -1. It's not visible. It is -1. What is this new value? -1 by 2. It is 0.5. That is 1 by 2 you can write. 0 by 2 is 0 itself. Then 1 by 2, it is 0.5. Then 2 by 2, it is 1. Okay. Now, this was your given range, that is -2 to +2. What new range you got? It is -1 to 1. That's why I said when you do time scaling, if the first condition is met, it means your output is compressed. The signal range for time, it gets compressed. Earlier it was -2 to 2. Now it is -1 to 1. So what I will do, I will take this a little bit expanded. I'll take. I will mark this as -1. Okay, a big range I will take. No doubt it is 1 unit only. Just to show you the detailed signal, I'm taking a bigger length. But it is 1 unit only, between 0 to -1, between 0 to 1. Now, we will try to mark the amplitudes now. Okay, amplitudes for the changed signal, this output. Now, let me erase this part. what is the amplitude between -2 to -1? Between -2 to -1, the amplitude is 1. This is the given signal, right? So that will exist now between -1 to -0.5, okay? -0.5. So whatever the amplitude exists between these 2 points, 1 unit, -2 to -1, 1 difference, it is now between -1 to -0.5. If I mark this as -0.5 and this as +0.5, let me mark it, -0.5, minus half, and this is +half. Then whatever this signal, let me just erase this. Okay, this particular signal, a step in between -2 to -1 is now between -1 and -0.5, something like this, a step. Okay. Now, coming to the next point, we will take the next one set between -1 to 0. Okay. Earlier, -1 to 0, you have this amplitude. Okay, a step. But now, what is the new time range? New time range will be -0.5 to 0. That is, this should be continued between -0.5 to 0, one more step. Okay. Similarly, coming to the right hand side, earlier between 0 to 1, this existed. Now the new range is between 0 to 0.5. So 0 to 0.5, this is continued. After that, between 1 to 2, the range was, the signal is like this, one more step, amplitude is 1. Now the new signal range is 0.5 to 1, 0.5 to 1. Signal looks the same, just the time is different. If you see, just compare this signal with this signal. Both looks same. Just this is the original range, -2 to 2. The new range is -1 to 1. The signal got compressed in terms of time. How we got this compression? By dividing each time value by this A, what is given as 2. So whatever time is there, you just divide that each time value by 2. And whatever value you get, you put that as your time here. -1, -1/2, then +1/2 and 1. So this is your new range, and whatever these signals look like, draw it as it is. This one more step to the down, then one more step to the down. So this is x of 2t, 2 times t, wherein it is greater than 1. A value is greater than 1, hence the signal is compressed. Now let us take one more example wherein A value given is a fractional number. That time it is given here, the output will be expanded version. So obviously the range will not be now -2 to 2. Expanded means it will be more, bigger than this. Let's see what it is. This is the example, half of t, x of half of t. What is A value? A is 0.5, half, which is in between 0 to 1. So second condition applies. Hence, we need to go for expanded version. How to find the expanded version? Let's see. This is your original times, -2, -1, 0, 1, 2. Original time values. In case of compression, we divided each time value by 2. Here we should do it reverse. That is, each time value should be multiplied by 2. Actually, it is divided by that value only, half divided by 1 by 2, which will go to the numerator and becomes 2. Okay. I hope you understood this point. What you have to do? Whatever factor you have, just divide it by that. This will go to the numerator, that is 2. This 2 you multiply to all the times. How will you do that? The first value is minus 2. Minus 2 into 2 will be minus 4. So that's what the range, left side range is minus 4. Then it is minus 1 into 2. I hope you are understanding why I am multiplying it by 2. Actually, it is whatever time is there, it is divided by 1 by 2. This 2 will go to the numerator because denominator of the denominator comes to numerator. So it will become t into 2. So t is minus 2, minus 1, 0, 1, 2. Just substitute it. So if you take minus 1 into 2, you will get minus 2. This point. Then 0 into 2 will be 0 only. Then 1 into 2 will be 2. And 2 into 2 will be 4. Okay, first mark all these points. In between points also, for continuity purpose you can mark. Okay, because only even numbers are there. So you mark all. Minus 1 and minus 3. Now, if you observe, the range minus 2 to minus 1, between these two, we have this step. Okay. Now, what is the new range? It is minus 4 to minus 2, new value of the time. When you multiply it by 2, it is like this. Hence, this shape, I will expand it. Similarly, between minus 1 to 0, we have one more step here. Okay, amplitude is 2. It is reaching 2. Now, what is the new range? It is minus 2 to 0. So that step, one more increase, amplitude 2, I will extend. Similarly, on the right hand side, the range for 0 to 1, between these two, there is down step. Okay. Now, what is the new range? It is 0 to 2. So, this is down step is extended. Now, between 1 to 2, there is one more down step falling from 1 to 0. Now, new range is 2 to 4. Hence, this falling from 1 to 0. I hope you understood this. With this, we got expanded version of x of t. I will just zoom out so that it is clear to you. Okay. Compare all these three signals. This is your original signal. This is your compressed signal, where time range, you divide it by a. Time range got compressed. For half of t, you multiplied it by 2. Division of 1 by 2 will become 2, multiplication of 2. So you got expanded version, minus 4 to 4. Shape of the signal is same. Observe it. Observe one step, a step. This shape is retained in all the three figures. And check the amplitudes. 2 and 1. Here I have not marked, but it is 2 and it is 1. Here also it is amplitude 2 and 1. So if you observe, we have not touched the amplitude part, vertical part. We are only interested in time, horizontal axis, because whatever a value is there, it is associated with time. Okay, so I hope you understood this problem. Any doubts, please you can ask me. Unmute and ask, or you put it in the chat box. Don't worry, at once you will not understand everything. Okay, a little bit of understanding is also okay. As and when we proceed, you will understand it better. Ma'am, why should multiply by 2 only? Okay, very good question. As I told you, it is actually the a value. A is important. Whenever you have a time, here in this case, the first case, when it is greater than 1, we simply multiply by that a. Okay, as a is 2, we are multiplying it by 2. In the in the first case, as it is a, as we want it compressed, what we have to do? It is not multiplying, it is dividing. Okay, whatever time value is there, we divide it by a. Okay, that a is 2 here. Now in the second case, when the a value is between 0 to 1, that is half, 0.5 for example, signal should be expanded. In order to get the expanded, greater value, you should have some multiplication, obviously. It is actually like this: t of that a value. A is given as 1 by 2. Hence, denominator of the denominator comes to the numerator. You will get 2. Remember, whenever you want a bigger value, you multiply. Whenever you want a smaller value, compression, then you will divide. This is a general thing, right? If you have a container or a cube of length and width 6x, if you want this to be of reduced size, compressed size, you will take the size, divide by some ratio, okay, equal value, you divide it, then only you will get a smaller version of it. So in order to get the smaller version, division operation is important. Now if 6 by 6 cube is already there with you, if you want a bigger value, bigger cube, you will simply take the multiplication by some common value, by say 2, 3, 4, whatever, so that original is this, bigger size will have a multiplication. Okay, division, we will go for division because we want a compressed version. That's why here when we want time, we divide by a. But for expanded version, as we want bigger time value, we will go for multiplication. Remember this. Any other doubt? And it is not 2 only, it is actually a. In general, it is a. Okay. No other doubts? So everyone understood? There are two meanings of keeping mum. Either you understood everything or you did not understand anything. What should I assume? You can unmute and answer me, no issues. Understood. Okay. So I hope you understood. Even a little bit of understanding is also okay, because we will be solving many problems. You will understand it thoroughly. Don't worry. So let us take one more example. I have taken this example for continuous time system. Okay. Let us take one more example for discrete time. You'll understand hopefully. Just like continuous time signal, there it was y of t equals to x of a into t. In case of discrete, y of n will become x of, you can take a also, no issues, k into n. K is that value. Okay. This is x of n given to you. What is the range? Let me just take it zoom in version of this. Yeah. This is x of n given to you. The time range is -3 to 4. Okay. Now, what we need to find? It is x of 2 into n. So, the first condition is satisfied. 2 into n means what? A is greater than 1. So, here also it is shown here. K is greater than 0. K or A, whatever value you take. So it is greater than 0. So compressed version of the signal you want. In order to get the compressed version, you should go for division. Okay. So to get the division, what factor should be divided? It is given k value is 2. Hence, what we will do? We will simply take this range. You can see it. I have divided. I have marked it with the pen. You have to divide all the time by this k factor, k, 2. Okay. If you do that, what you will get? Let's see the new time range. -3 by 2. What is the value? -1.5. And the -2 by 2, it is -1. -1 by 2, it is -0.5. I will write it like this. I don't have space here. Then 0 by 2, 0. 1 by 2, I will keep it as it is, plus 1 by 2, no space. 2 by 2, 1. 3 by 2, plus 1.5. And 4 by 2. 4 by 2, it is 2. This is the new time range. Earlier it is -3 to 4 range. Now the new range is between -1.5 to 2. Discrete signal scaling is very much easier to you. There is no manipulation. Whatever amplitude you have there, you simply put it. That's it. One more important thing to remember here in case of discrete signal is, if you are getting time in fractions, see here, this is a fractional value, this is a fractional value, 3 and 4. 4 different points are having fractions, -1.5, minus half, plus half, and plus 0.5, 1.5. So 4 values are there. What you have to do, you should simply discard them. Don't consider them. Third, we don't want this, because we have defined a discrete time signal as the amplitude values at the whole numbers. Okay. So we generally tend to avoid these fractional time values. N is presented in the form of a whole number. That's why don't consider these points kind of time. Simply discard it. And whatever remaining amplitudes are there, how many are remaining? Check it. This is 1. This is second. This is third. And this is fourth. These 4 points, you simply write it. That's it. What is the time here? It is -1. So at -1, write 0.5. What is the amplitude at 0? It is 1. So write it 1. What is the time here? It is 2. So at 1, write 2. And what is the time here? It is 2. At time 2, you have the amplitude 3. Here I have mixed it. I will take one more line. Something like this. Okay, this is the 4th amplitude. So if you compare the continuous time scaling with the discrete time, discrete seems easier. What you have to do? Simply divide it by that k value. Whatever fractional values are there, discard them. Only the whole numbers 0, 1, 2, 3, 4, -1, -2, -3 like that. Take only those values of time, and whatever corresponding amplitudes are there, put those amplitudes. It is as simple as that. Whether you have understood the second example? If you have understood, I'll move to the next. So in this session, we have completed time scaling. One example on continuous time signal, that is 2 into t and half of t. One is compressed, one is expanded. Similarly for discrete. So in the next session, we will be taking few more examples on time scaling, and if time permits, time shifting we will start. Okay. So I'm ending the session. Please rejoin as soon as possible. Thank you so much.